This is my breadboard RTC. Firstly, I'll show you what each part of the circuit is and what it does, and then I'll show you the whole circuit together. So the first part of the circuit that I'll show you is the 4 PNP transistors, and what they do is allow each digit to turn on at one time, so the other 3 are off. And while it appears like all 4 are on, only one of them is actually on at one time, and that's because of these PNP resistors. So what you'll see these yellow wires back here, and what they do is each of them goes to one of the PNP resistor's base pins. If there's a high, then the PNP resistor will not allow current to flow to V+, and what that does is it turns off the segment that it's attached to, and when there's a low, then it allows current to flow to V+, and then therefore the segment would be on. This is important because it allows you to choose which digit is on at one time, so that all the digits aren't displaying the exact same information, but rather 4 different numbers. So next I'll show you this actual RTC, and this is what keeps the time. So the most important piece to this circuit is probably the 32.768 kilohertz crystal, and this is what actually allows this chip to keep the time, because every second this will move 32.768 times, and so now the chip has a basis for what is 1 second, and then it can use that basis for 1 second to create time, date, and so on. And it uses code, the set time code, to learn what the current time and date is, so then it can build on that with this crystal. So everything starts here. This is what creates the time. That time will then be sent to the nano, and then the nano, through software, will then send it back out to this shift register. What the shift register will do is it'll take the data, which the nano is turned into binary data through using a segment map, and it'll send that out on these 7 pins into the 4-digit 7-segment display. The 4-digit 7-segment display will then display whatever data has been sent to it through, or highs and lows have been sent to it through this 595, and it'll display that on the 1 digit, but it can't display all the data at one time. It has to turn 1 on and display that data, then turn it off, then display whatever should be on the next digit's data. And to do that, you use these PNP transistors to turn all three of them off and leave 1 on, so it displays that data, turns it off, turns this one on, and displays the data that should be here. And that's how you see the minutes and seconds that you saw in the beginning of the video.